So previous recording will split into 2 times now. Because of the internet connection, it was disconnected directly. So it has stopped its recording automatically. Now it is converting here. Where we have stopped this block, na? Okay. What we have to do? The 30 MVA transformer. First, we have to consider three-phase supply. That supply, the output of the generation will given to the input to the transformer here now. So 30 MVA, 11 kV bar, 400 volt. We are stepping down the voltage here now. So I have to double click on this one, choose parameters. Here you take that one, the 30 you set here, and 30 into e to the power of 6 is nothing but that is how much it is. E to the power of 6 is nothing but that is 30 MVA. The frequency we have to set into 50 here now. Again, you have to set the frequency into 50, and the winding one input is L1 kV, and it is resistance of that winding and inductance of that winding. No need to touch that one. Winding 2 we have to set into 400 volt. We have to set the 400 L1 kV to 400. We are going to get, click apply and okay here now. Next, what we have to do, we have to click on the circuit breaker. Click on the circuit breaker. Here the open or close. If it is open, switching off, you can off the particular phase also here. Switching off is nothing but phase A, phase B, phase C. It is off now. It will be act as open. So for that reason, what we have to do, we have to make this one as closed, and we have to unmark these all the phases here now. The switching time also we can enter here now. So I have set this one as 0 now. The switching time I have set it as 0 here now. So we can set the switching time 0 only. I will tell that one, switching time 0, and breaker resistance that is 0.01, and snubber that is automatically it will take. I have to first apply and okay, no problem. It is automatically applied now. So voltage measurement, we have to take that one. Again, this is phase to ground voltage we are going to consider. So that one we have set it already. Next, the load voltage and frequency, we have to set all the things now. So the nominal voltage, what is the VRMS, that is called 400. The frequency we have set it into 50 here now, and other things at we let it do as it is here now. So I have done all the things here now. The scope already I have used. I have used one 3-phase fault, but I have not connected to this 3-phase supply here now. So everything is set now. What I will do, I will run this model now. I will run this model. What will happen? We'll check that one. Still it is taking time. See here, it is taking the time. 2% is over now. Let it to complete 100%. Paused, okay? Why it is paused? I don't know. Okay, now it is completed the simulation. I will click on this scope. Double click on the scope. Check that one. What we are going to get exactly the output is came or not. We can set that one. Okay, see here now. See the phase A, that is called yellow color. It is considering here now. So it is started from 0 and 1 per unit. We have matched that one, positive, negative, like that. It is continued here now. So the phase 2 after 120 degree, that is blue line, it is going to indicate it came here now. and phase 3, that is red line, it came here. Now can set the tool colors also, change that style. I don't know exactly where it is display, not here. I will right click on this. Okay, here the style will come. Can change the color also. No, nothing to worry about that one. Everything will be manageable. The plot colors are there, the background, whatever the auto plot type it has taken, lines, axis color, it has taken this axis color is, that is brown color, and visible here now. Line, it is, which one it has taken, yellow color we have taken. So you can consider that apply. See here, it change it to red now. So active display, one is there, 3-phase measurement, that is measurement 1 ko red color fix key. Next for this one, blue, I will set that one. I will set apply, that is blue. And the third one, RY, second ko Y karoge. Okay, RYB, I will set as phase 2 ko yellow. I will set that one, will be yellow. And for the phase 3, I will set that is called blue color. Okay, now this here now RYB, 3 phases we have set it here now. So anybody, can you reply? Is it visible nicely? The 3-phase supply is there. 3-phase supply is given here. Yes or no? The output, is there any disturbances here? Waveform में कुछ disturbance है क्या? Starting from 0, smoothly they are operating here now. The operation is normal here now. There is no abnormal conditions at all. Okay, there is no any faults or overloading and all the things. For the normal load, they are operating in the normal condition. They are operating here now. What I will do, I will keep this one as it is. Here I have one fault. I will apply here now. A to A, I will apply here. B to B, I will apply here. And C to C, I will apply here. And I will click on, double click on this one. Here the initial status is 0. I will consider here ground. I have fixed that one. Line to ground we are going to consider. Phase A, I will click on that one. The switching time I will set as 0.02 to 0.04 here now. The switching times is nothing but this one here now. Where it is, this is 0.01, 02, 03. This one we are going to consider here now. 0.42 to 04. Up to here, this red color line, it should have to interrupt here now. Now you can check that one, 0.2 to 0.4. Is there any interruption here? Is there any interruption? No, normal operation is there. What I will do, I have set it this one, and I will apply phase A to ground, and I will click OK. I will run now. It is compiling now. Once it is okay, it is completed. It's run simulation is completed. I will double click on this one. See here, there is a change in voltage, red color. Anybody, can you reply? Yes or no? Here from 0 to 2 it is normal only. From 0 to 2 it is normal only. The switching time, when the fault occurred at 0.02, suddenly what will happen? The voltage was 1 previously. It is reduced to 0.6 here now. Is reduced to 0.6 or not? Yes or no? What is the value here now? अरे बाप रे, आप लोगों को पढ़ाना बहुत मुश्किल है. फिर I will change the subject. I will go for second year then. I'm telling that one. I am already having so much load of SYA, B, and then also I am taking the subject for you people. If you people are not ready to interact, then I will set this subject. I am not going to handle anything then. Is it visible or not? All of you?
Yes, sir.
Yes, sir.
To whom we have to explain then? Nobody is replying means I have to explain to this laptop display. You want to learn something means you try to interact. Whenever I will ask question or anything, you have to reply. Otherwise, simply sitting silent means to whom? Or I have to do that one. Whatever it may be correct or wrong. Try to interact first. The voltage is reduced or not here?
Yes, sir.
Huh? Again, everyone is silent now. This is very bad. You peoples are in final year, but nobody want to interact. Okay, then I will not ask anything here now. See, whenever we will apply the fault to phase A, the voltage will reduces here now. So the voltage reduced here now, it is under 0.1 to 0.9. So this is called, we are going to call this one as a reduction of voltage, that is called sag. We are going to tell that one. This is called sag here now, reduction of voltage from 0.1 to 0.9 volt. In between, if the voltage is fault, that is called sag. We are going to call that one. Similarly, for the other phase, instead of the line phase A, I will choose the phase B here now. I will click on this and I will click apply phase A to, sorry, phase B. I will consider that phase B. I will consider that here. So again, I will run. Where is the run option? Okay, I will run this one. Is compiling now. Now the phase B I have selected. The whatever the yellow color is there, it should have to reduce for the switching time here. See here, it is reduced here. It is also falls under 0.1 to 0.1 to 0.5 here. Now exactly 0.5 is that here. So that voltage we are going to, that is sag, we are going to consider here. 0.2 to 0.4, actually 4 and in between 5 also it is considering here now. So 4 point something it is considering here now. So next, for the phase 3 also we can do, that is instead of phase C, phase 3 also we can do here now. I will select phase 3, but the switching time I will change it to different now. Instead of 0.2, I will take 0.15 to 0.3. I will consider that one. I will click on apply and I will close that one. Okay, next I will run the simulation. So you can do that one. You can check the here now. So for 0.15, where 0.01 and 0.02, in between 0.15 will come. So suddenly it is dropped here. The spike came here now and the voltage is reduced here. Okay, this voltage is reduced and it is again normal for after this 0.35 here now. 0.35, it is normal and it is operating under normal condition. Only during this particular time period we are applying a line to ground fault. We are applying here now. We are applying line to ground fault. We are applying. Based on that, the voltage is decreasing here now. Based on that, the voltage is decreasing. Suppose I will try to apply, instead of one phase, what I will consider? I will consider phase A, phase B and ground here now. Two phases I will consider now. What will happen? We'll see that. Okay. Phase A and phase B with respect to the ground, the two fault will be occurred, and that condition, what will happen in the output? I have to check now. I have to check the output. Double click on the scope. See here now. How they are doing here now. See, for the phase A, it is during the negative cycle, negative half cycle, the fault occurred. suddenly we tend to 0, and the negative voltage, it is instead of 1 per unit, small voltage it has came here. Now for the next half cycle it is small only. Here the fault is cleared, then it is normal voltage it is giving here. Same thing occurred for the phase B or Y. The fault occurred at this 0.015 for during the positive cycle. Here at this particular, suddenly it will fall to 0, and some voltage it will takes, and it will take the next step here, and at this point the fault is cleared, so it is moving normally for the next half cycle. Okay, suppose instead of this, what we have considered now, we have considered phase A and phase B. I will consider phase B and C. I will consider now phase B and C. Instead of this 0.15, I will consider 0.01 only. Okay, can different fault, different switching times, you can give that one. I will run the model now. I will run the model. The model is executed now. What we have, see here now. See here. At 1, I have created a fault. The time switching of the fault is 1 here now, 0.01. 0.01, the phase 2 was at negative side. Suddenly it went to 0, and some voltage it has dropped here now. And for up to 0.3 cycle, it is the reduced, and after that the fault is cleared, it is normal, it going to come. Same for phase B also here now. Phase B, it was in positive cycle. At 0.01, the fault occurred at this point. Suddenly it is going to drop, and the voltage will be reduces. After clearing the fault, again it will come to the normal position here. Okay, so this is the voltage sag experiments you can consider, or line to ground faults you can consider. You can check that one. And suppose instead of this one, what I will consider, I will consider all lines, all phase and ground fault here now. All phases I will consider. So particular time period, all the phases voltage should be less now. See here now. During the 1, 2, 3, it is less only. All the phase, it is 3.5 we have considered. So that one. So here the voltage is reduced. It is varying from 0.1 to 0.9 per unit. It is varying here. So this is the voltage sag, or reduction in voltage due to the fault or any overloading also we can call that one here. So any doubts? So if who is having the laptop, you have to perform this one. All of you perform. So by taking the printout of this one, you have to submit the file to get the ICA marks as well as for the oral examination. So you have to maintain the record of this one. We are conducting the practical, means you have to do the write-up of this one. Everything is in the under simulation only. You can take the title of that one, measurement of voltage for during the line and line to ground fault, and you design this model, take printout, and you can explain that one, line to ground fault theory and voltage sag theory. You explain it, and how you are going to perform this practical based during the MATLAB, open MATLAB. Go to the library, Simulink, then go to the library, take the blocks, join all the blocks, click on each, double click on each blocks, and set the values, run it, click on the scope, and this one you can enter the title also here now by double clicking on this one. Just a minute, I'll close this one here. By double clicking on this one, you can enter the name here, measurement of voltage for line to ground fault. I can type the name, and even by selecting all this one, where it went, can double click on this. Then you can choose. starting only I will consider this one. So I will double click on here. You can change the font size here now. Instead of small font size, I will take this one as 24, and the color of this one I will take dark red. I will take that one. So you can write measurement of 22. Where it went? Getting this one. कुछ तो ऑपरेट ही नहीं हो रहा है अभी. Just a minute. Let it complete. Still it is not responding. I think it is hanged now. Not operating anything. So this is the simulation. It is not operating at all. You can give the title of this one here. You can write the title. Already you have done this for this type of experiment. Here you give the title. In the downside, you write your name, roll number, and class. And you double clicking on the scope will get the output also. You have to take the output. Also, you have to take that one. The waveforms. It's not operating at all. Now it came. What it is going to operate? See here. How it is operating. Now you can check that one. The block is very bigger now. Okay. So this waveforms also we can take that one by making the print display to figure. By clicking on this one, it is going to save the image copy. You can take this one also. See here, this is the image. It came here now. By taking this one, we can do the printout of this one. So will you do this one? Double click on this measurement of voltage for line to ground faults. Okay, take this one, and here this side you can write your name, your roll number, you can write the class like this. You can write and you can take the print here. The reverse okay, name. Okay, roll number, name, roll number, class, and all the things you can write here, and you can take the printout of this one. All of you have to perform. I don't know when if you have the laptop, you perform it. Otherwise, after visiting to the college for the offline session, you have to perform this model in the computer lab. Okay, all the computers are installed. Now in all computers, MATLAB is already installed. You can use it, utilize it, and you have to perform this one. Okay, any doubts?
No, sir.
अभी श्रद्धा जोश में आ गई अभी एटलीस्ट रिप्लाई दे रहे. थैंक यू श्रद्धा. What will happen? We'll feel like that one to whom we are explaining. Interestingly, we are explaining something means that is helpful to you people only. It is not helpful for us. You people are not understanding that. See, I will tell that one more thing. Some people, why we have to go for MATLAB, this one, all the things. Even if you know the MATLAB, now the trend is came now. A few days back, I have discussed with one of my friend who is working in US. He's told that one MATLAB is a trend now. The peoples are not what that one. They are searching the peoples who is perfect in MATLAB. So try to use this one also, and you learn this one. When so many things are there. Okay. Whatever we are explaining, I'm explaining means I know only 5% only. 95% is remaining. Related to electrical, I know that one. But have you seen this one? where it went? Not this one. Models only. Library. All of you have seen this one. I click on the library. See here. I will just. How many operators are there here now? See here. Simulink, aerospace block set is there. Audio system is there. Communication system toolbox is there. Communication system toolbox HDL support. So many blocks are there. Again, in that one, by clicking on that one here, see a Simscape, we'll get so many pair. Next, again, in this one, so many blocks are there. There's all the blocks, we have to be perfect in that one, then only we can do that one. But here I can say that one we are not this much perfect. We are in the field of electrical only, we know that one. That too, my field is power system. In the power system, I know which block is where and all the things. Other people's, what they have to do, the designer, how they have think and how they have taken this, all the things. You just think that one. We has already done the developed the software, we are not utilizing that. Okay, learn something. You will learn something for this one. So you practice it, you'll see that one. In the next practical, we'll take another experiment, we'll take that one. So I will not waste much time. 8 practicals slot, 8 practicals I will complete. This is the first experiment is over. I can say that one declare. Okay, because I have shown all the blocks, how we have to take the blocks, how we have to connect, how we have to set the value, how we have to run for different line, first phase to ground, second phase to ground, third phase to ground, and first and third, second phase to ground, first and third, second and third, and all the phases with ground. That also have performed this one. So if we have considered here, only 6 experiments will be over for this one only. For each phase differently and phase to phase like that. Okay, so just a minute, I will take the attendance and we will stop here only. Roll number 1. Now it is the attendance time. I will not repeat your roll numbers. You have to say.
Yes, sir.
Okay. Roll number 1 हो गया, 2 absent, 3 absent, 4 5
Present, sir.
6 7
Present, sir.
9. Roll number 9. 9 absent, 10 11 12
Present, sir.
13 14 16. Roll number 16 17 18 18 नहीं absent, ठीक है. 16 17 18 19
Present. Yes, sir.
19, yes, 19, 20 absent, 21
Present.
22 23
Present, sir.
24 25 absent, 26
Present, sir.
27 27 है क्या? Absent, 28
Present, sir.
हाँ से I was 28 हाँ.
हाँ, sir. Present.
Okay, 29 30
Present, sir. 29.
29 present है क्या? Service okay, starting is anyway. Okay. 30 31
Present, sir.
बोराटे आदित्य बोराटे एक काम करो मेरे को, एक मिनट. बोराटे नहीं है, ठीक है. 32 33
Present.
34 35 35 absent, 36 37 38 39
Present, sir.
40,
Present, sir.
41, 42, 43, 43 absent, 44, 45, 46, 47, 48, 49, 50, 51, 52. Next 53, 53, 54,
52, sir.
52 present, eh? Good join,
Yes,
okay.
sir.
53, 54 present, 53 absent, take it. 55,
54 present, sir.
54 present, ठीक है. 55, 56, 57.
Present, sir.
Okay, 58, 59, 60, 61, 62. 62,
Present, sir.
63,
Present, sir.
64, 65, 66. See, whenever you will enter into the meeting, on that time only I will mark. If while taking the attendance in the last, if you are not there, then I will put that one dot, that is nothing but again absent for you. Join करके फिर वापस exit हो गए तो that is not, I am not going to consider your attendance. Should have to present in the start and the end. Starting में red mark रहना चाहिए और last कोई dot नहीं रहना चाहिए. So the intention of taking calling your roll number is how much alert you are. You are listening the class or not. That one I want to check. For that reason I'm calling your roll numbers. So the second year, third year I didn't call that one, but for you people, I came to know that one you people are simply joining the class and not attending anything, not responding. So for while giving the attendance, how many of you will reply? I want to check that one, and who will reply for those people only they are going to get the attendance. Okay. So कोई कर रहा है क्या MATLAB में प्रोजेक्ट वगैरह है क्या किसी का? Anybody project is there? No. And one more thing, Monday, Tuesday complete project part is there. You have to discuss with your respective guide. You have to update your status. I'm not telling to my batch. I'm telling that one. Approach your guide to discuss what is the status of your project, what is the percentage of our completion, what is the left, how you have to do to plan according to and convey to your guides, respective guides. Okay, so we'll stop here only. We'll continue in the next class.